Okay, so for the first one, again, what you want to do, right, is what you want to multiply by pi divided by 180 degrees, okay? That's what you want to do. So for 100 degrees, right, what you want to do is you multiply by pi over 180 degrees, okay? And of course, that's equal to 100 degrees times pi divided by 180 degrees. And of course, you can reduce that. The degree symbol goes away. It looks like an exponent here, but it's really not an exponent. So that's gone. And you're left with, and also you can actually cancel a 0 from the top two. In other words, you divide both sides, top and bottom, by 10. And you get 10 pi over 18, but 10 and 18 have a common factor of 2. So you actually reduce this to 5 pi over 9. I mean, normally you don't have to reduce it. That is, you don't have to write it in lowest terms unless I tell you to, but you really should cancel the degree symbol. Like I did, at least. You really should cancel that. And again, we don't write out pi in decimal form. I know pi is about 3.14. I've seen people in the past, they would write it out in decimal form here and then multiply by 5. Don't do that. You're really not supposed to do that with radians. For the second one, part B, you have 200 degrees times pi over 180 degrees. And it's the same idea. You get 200 degrees times pi over 180 degrees, right? The degree symbol cancels, okay? And 200 and 180 have 10 as a common factor. So that's what I did here. Here, let me get the document up. So to get from here to here, I canceled 10 from top and bottom. I divided top and bottom by 10. And then also both top and bottom have a factor of 9. So I canceled out that factor as well. All right, so we have that. And finally, for 300 degrees, same idea. You multiply, you get 300 degrees times pi over 180 degrees, and you keep on reducing. You divide top and bottom by 10. How do you know 10 is a factor? Because 0 is the last digit. If 0 is the last digit, then 10 is a factor of it. Mostly because 5 and 2 are. Then I canceled 2. I got 15 pi over 9. But 15 pi over 9 also has a factor of 3. So I canceled that as well. But again, you don't have to reduce all the way. If you stopped, let me see. If you stopped here, for instance, or I guess if you stop here, but you took away the degree symbols, that's fine. You don't have to write in lowest terms unless I tell you to. I know technically you're supposed to know how to do that, but I didn't really go over it, so. But that's number one. Again, I usually would write out the solutions on Microsoft Whiteboard or something while teaching. Some kind of live, how do I say this? Some kind of whiteboard where you see the stuff done in real time. But again, Microsoft Whiteboard, I took it off my iPad. It was acting funny, so it kept crashing. So I don't know. Any questions on this, though? I will post the solutions, don't worry. All right, so for this one here, to go from radians to degrees, here you basically multiply by 180 degrees over pi. And again, the pi's are generally not going to be in your answer. That will happen. Okay? So for instance, here we have 4 pi over 5 times 180 degrees over pi. Okay? You multiply, what happens? Okay, so again, notice the pi's are going to cancel, right? You have pi on top here, you have pi on the bottom here. They're going to cancel each other. You're left with 4 times 180 degrees over 5. Okay. And that's actually 720 degrees over 5. And if you do the calculation, you get 144 degrees. So that's part A. Okay. Part B, it's the same idea, except you're multiplying by negative 3 pi over 4. And you're multiplying that by 180 degrees over pi. So just like before, what happens? The pi's, that symbol cancels. I know pi is a Greek letter, but it still does, it denotes a number though. So it's a real number here. And you're left with negative 3 times 180 degrees over 4. Okay, and again, what's 3 times 180 degrees? That's 540 degrees. So we have negative 540 degrees over 4, which is negative 135 degrees. That's what we get here. And finally, 2 pi over 9. Same idea. You have 2 pi over 9 times 180 degrees over pi. And again, it's the same idea. You can see you have pi in, let me get the document. You have pi up here in the top, right? Pi down here in the bottom. They cancel each other. Okay? And, oh, sorry, wrong button. I don't know what I was thinking. Sorry, I clicked that by mistake. So we have this, and then you can multiply, and when you multiply, the pi's cancel. You're left with 2 times 180 degrees over 9. And if you do this entire calculation, you would get 360 degrees over 9, which is 40 degrees. Well, let me add that in. No, I guess it's okay. That's fine. I mean, I know I didn't write down the step from here to 40 degrees, but, you could do that in your calculator easily. Okay, so that's for questions 1 and 2. Are there any questions on that? Okay, so now let me get to question 3. For question 3, you're going to use a, wait, no, sorry, wrong file. Okay, let me get back the actual worksheet. Let me, let's see, I almost showed you guys I almost showed everyone the answer key, which I don't want to do yet. That's okay. So for here, you have this triangle and you're going to do question 3. Notice that question 3, you're basically assuming, 2 sides of a triangle are given, find the third side, okay? And you're going to find some trig functions. You're not going to try and find the angle though, okay? Don't try and find what theta is equal to. Okay? But how would you get the length of the third side? The unknown side, that's Pythagorean's theorem. So, okay, so I'm going to stop the recording and, take about like 4 or 5 minutes to do question 3. I think question 4 actually is similar. Let me see. No, 4 is a different one. Okay. 3 has 2 parts to it. So work on question 3, please. Also, before I forget, I did put some practice questions from the textbook, on Blackboard. Just letting you know, it's in the same place where the syllabus is. So, I mean, you don't have to do them, but it's recommended.